Pharmacodynamics. As I told you, it is nothing but the study of the mechanism of action of drug. Mechanism of action of drugs, or in the simple language, what drug does to body. What the drug does to body. Or you can also say it's a study of the impact of drug on body, or otherwise it is study of biochemical, physiological effect of drug and its mechanism. So these are the different ways by which you can define the pharmacodynamics. Mechanism of action of the drug, what drug does to the body, impact of the drug on body, study of the biochemical and physiological effect of drugs and its mechanism. All are one or more or less, they are similar. If somebody asks you what is pharmacodynamics, you may reply in this way. You must be able to explain them. Now, drug action and drug effect. What is difference between these two? Action and effect. How equation check? Some effects are produced because of the some action. Some actions are produced because of the some effect. બરાબર? લાઈફમાં પણ આ ઇક્વેશન હોય છે. ઘણા કામ આપણે કરીએ તેની ઘણી બધી અસરો ઊભી થતી, ઘણી બધી અસરો આપણી ઉપર થાય એટલે આપણે અમુક કામો કરતા હોઈએ. Now, drug action. So you can say the drug, when it acts and combines with the receptors and produce the effect. So the manner or method by which it produces pharmacological effect is known as drug action. Is known as drug action. Now drug effect. So what do you mean by drug effect? Effect એટલે શું? Response of body to drug. Now let us try to understand action and effect. Paracetamol, it's a analgesic or painkiller. If you take it, what it produces? It reduces the body temperature. Okay, it reduces the pain. How paracetamol reduce the body temperature? How paracetamol reduce the pain? That is known as action. So it reduces the synthesis of inflammatory mediators by inhibiting enzymes. So that is drug action. Because of that action, we are getting the reduction in the body temperature, we are getting reduction in pain. That is drug effect. Clear? We will take another example. Say for example, blood pressure. We are taking the atenolol, beta blocker. Say drug. It combines with the beta receptors, and there may be series of the biochemical and physiological reactions which will produce the reductions in the blood pressure. So this is action and this is effect. Somebody say describe the pharmacological action or drug action of paracetamol, then you are supposed to give the mechanism of action, that it combined with the cyclooxygenase to inhibit the enzyme cyclooxygenase, reduce the synthesis of the prostaglandin and thereby reduce the synthesis of the inflammatory mediators, and by that way it reduces the inflammation, pain and fever. That is action. If somebody says to describe the drug effect of paracetamol, then simply effect. If you take the paracetamol, what you will feel? I feel reduction in the body temperature, reduction in the pain, reduction in the inflammation. So that is pharmacological effect. Clear? Now, receptors. You have studied the receptors in the physiology. So, what is receptors? It is nothing but the macromolecules of the cells, which may be located in the cell membrane, outside of the cell membrane, within the cell, within the nucleus. You have studied extracellular receptors, membranic receptors, intramembranic bromine receptors, then nuclear receptors. So it's a nothing different story. Receptor is not a different thing. It's a part of the cell. It's a macromolecule, and most of receptors till the date whatever we are knowing, they are protein in nature. So it's a macromolecules of the cells with which drug combines. We are learning pharmacology, that's why we are taking it as a drug. Otherwise, if we are learning physiology, then the receptor has capacity to combine with any endogenous or exogenous substance. Right? And they are highly specific. Maybe or may not be selective. You have studied the lock and key border. So what it suggests for particular enzyme, particular substrate is there. એવું છે ને? બધા રિએક્શન માં ના ચાલે. એક એન્ઝાઇમ એક સબસ્ટ્રેટ ની સાથે પેલું કોમ્બિનેશન કરીએ કે one key one lock. So that is highly specific. That means each drug has specific receptors. Macromolecules, then each drug has specific receptors. They may or may not be selective. So what is the meaning of this? Selective may or may not be selective in the effect. Say for example, one drug combines with the beta receptors or beta 2 receptors. It is not it is not combined with any other receptors in the body, only beta 2. So it will affect the functions of the heart only, because these beta 2 are predominantly found in the heart. So that is selective. Now example of the non-selective, instead of beta blocker, if it is a generalized beta blocker, so it will block the beta 1, it will block the beta 2, it will block the beta 3. So in the tissue, in the body, wherever this beta 1, beta 2 and beta 3 are located, they are inhibited or blocked by the drug, and it will produce the non-selective, that means general effect. So getting what I am telling you? Is still confused? Okay. So highly specific may be selective, non-selective. Now the drug combined with the receptors, and it will produce the drug receptors complex, reversible. So drugs interact with the receptors and forms the drug receptor complex. This process is reversible. This process is reversible. That means in that way this reaction can also proceed, in that way it can also proceed. Now the bond between drug and receptors, they are weak bond. Weak bond kaya kaya છે? Hydrogen, then van der Waals and ionic bond, covalent bond. They are strong. So these weak bonds are present between the drug and receptors as they are weak. So as the time passes, this drug and receptors will proceed in this direction. That means drug is released free, receptors will be reutilized or recycled. And it obeys the law of the mass action. What is this? Law of the mass action. એટલે શું? ભૌતિક શાસ્ત્ર આપણે ભણી ગયા. આપણી નજર સામે જે કંઈ બને છે એને આપણે ભૌતિક શાસ્ત્ર કહીએ છીએ. ફિઝિકલ પ્રોસેસીસ, ભવમ ભવામી, એનું શાસ્ત્ર એટલે ભૌતિક શાસ્ત્ર. એવું અઘરું નથી એમ. So what is law of mass action? શું? ઓકે, ભેડા હતા આનું માસ છે, આનું માસ છે, આ બેનું ટોટલ માસ છે એ પ્રોડક્ટનું માસ હોય, બરાબર? એવું છે ને? હવે આનું માસ તમે વધારો આ બંનેનું, તો આનું માસ વધે, આ બંનેનું માસ ઘટાડો તો આનું માસ ઘટે. In nutshell, what I want to convey is that higher the concentration of the drug, higher will be the combinations of the drug and receptors, and more will be the response. Vice versa, lower the concentrations of the drug, because receptor population is a constant in the body. Lower the concentration of the drug, lower will be formations of the drug receptor complex, and lower will be response. So that obeys the law of the mass action. Clear?